Okay, so let's go ahead and introduce here database development. All right. Oh, I should share the slide screen over there. Okay. All right. So what we're going to talk about in this is our outline is the main components of a system. All right. What are the main stages of the development database system development life cycle? And just basically some of the main phases of the design itself, the conceptual, logical, and physical design. Now, this is just going to be, this particular set of slides is just kind of an overview of all of this stuff. The later, towards the end of the semester, we'll talk about these particular parts, the conceptual, logical, and physical design in detail. And then also some of the other parts, the main stages, we'll talk about that in more detail too. This set of slides that we're going over this week is just kind of a main overview. All right. Okay. I don't want to talk too much about the history of all this, but basically, actually, I do kind of want to talk about this because this is kind of something that I find really important, is the whole concept of software process, software engineering, software quality assurance. These are all really stuff that I like to talk about frequently because of how important it is. So basically, the way that what's it called? The software development. The way that a lot of programmers want to do software development is probably the way that many of you did your first CSE 101 and 102 projects, or your assignments. Is you got the assignment, it said make a method that does this, or make something that does that, or make the program output this after getting this input from the user, and you just kind of sat down at the computer and started typing away. Right? Let's see if this works. Click compile. Oh, it works. Okay. Great. It compiles. Oh, it doesn't. Let's see. Let me find the errors. Okay. And really what kind of came out of that was that so many projects were late because they weren't planned well. They were over budget. They cost more than they were supposed to. They could be unreliable because they weren't thoroughly tested. This is where software quality assurance comes in. Difficult to maintain because a lot of times one programmer would write it and then they might write it and stuff wouldn't work, so they'd go and they'd edit it and they'd just kind of like do whatever worked, right? They might take something that looked kind of right and looked like it might work. They tried it, it didn't work, so they tweak it and they'd mess with like this line or this line. And what would happen is that programmer then would leave the company or would be put on a different project, and someone else would come in to maintain it. And that new person would be like, I don't know how to read this. I don't know what this is supposed to do. Or sometimes even programmers themselves would look at code that they had last written years and years ago, and they would say, I don't remember what I was doing here. Why did I write it that way? And especially as we learn more and more about how to do software better. Okay, so what kind of came out of that was this whole concept of software engineering and the whole concept of software process, to be able to plan projects before we start making projects. All right. So again, some of the major reasons for why software fails: lack of a complete requirement specification. We didn't know what we were making. Like we didn't have a very solid understanding of what the requirements were as programmers. Some type of development methodology. So a plan. How are we going to develop this? Not just what are we making, but how are we going to do it? And can we apply that same development methodology to other projects? Planned phases of a design phase, a development phase, and stuff like that. And then poor decomposition into manageable components. I talk about this quite frequently, where I say the heart of engineering is to take a large problem, divide it into smaller sub problems, and then solve those sub problems. And then put our solutions together so that we can have one overall solution. Right? But if we just try to say, this is our big problem, let's just start writing some code that makes it happen, we can have some really problematic issues later on. Okay, so let's talk about the life cycle. I'm going to skip this slide. So let's talk about the life cycle, some of the life cycle of a database system development. And if you take the word database and change it out with any type of system, this is basically the same life cycle for almost any type of system. The planning phase, you do need to have a plan for how you're going to, don't just start creating tables right and left. Plan out how we're going to create those tables, how we're going to put in those constraints. System definition, what is the system boundary? We want to make sure that we're making what we're supposed to make and nothing outside of that. One thing that we often do when we don't make a plan, sometimes what we can do is think about aspects of the system that we're not responsible for, but someone else is. And that can be a big problem because we were wasting resources and we're wasting time thinking about aspects that we're not responsible for. Let's say, for an example of this, let's say, I don't know, Hepsi put it out, I want to order some wireless headphones. I got these like wireless headphones, right? And I want to order those, and I don't know what company. What company is this? Pell? I don't know. And let's say I want to order these from Pell. Well, Hepsi put it out, they don't need to know how those wireless headphones are made. They don't need to know anything about how the headphones themselves are made, right? They need to know certain specifications that they can pass on to us. What's the size? What's the distance that the Bluetooth can work with, you know? But they don't need to know the main points of how it's made, right? So they don't worry about that. Okay. Some other parts of this, requirements collection, make sure that we're going through the process of collecting requirements, figuring out what it is we're supposed to be developing. We'll talk about that. Then, of course, the database design itself. The selection of the DBMS. The reason why this is called optional is because sometimes this selection is done for us. So there's lots of possible DBMSs that we can choose from. There's someone, who was it? Someone posted a great article about that in here. Recep Tayyip, all right? So posted a great article about comparing the different DBMSs, the different SQL databases, right? We want to be able to compare those, but sometimes somebody else has already chosen, the customer, our company, whatever, has already chosen those for us, and so we don't get to choose those. All right, that's why it's optional. Application design, that's part of it. We do want to make sure that we design the application well to integrate with our database. Prototyping, creating a version of the application or the database, an application that's got minimal features. And of course, implementation, making it happen. Data conversion, maybe we're taking an existing data store, a database or something in Excel spreadsheets or something like that, and we want to bring it into our thing. Most important part, and not most, okay, not all this is all important. Testing. Testing is super important and it's often overlooked. Okay, we want to make sure it works well. And then finally, operational maintenance. Once we're done developing the database, we want to go ahead and maintain it over time to make sure that it keeps up with our developing needs. All right, so bird's eye view, we're going to look at this in the future weeks. We'll start on this slide, number 6, tomorrow. But as some of you have been asking, Hojam, what's the quiz situation? And you should have just gotten a notification. And just in case you weren't able to get to it there, I'm going to go ahead and post the link here as well. All right. So you have until 3:30 to fill out that. It shouldn't take you much time at all. All right. If you've been listening and following along in these lectures, you should be fine. All right. Thank you guys for joining, and I will see you tomorrow morning, bright and early.